Welcome friend, I am Smith Basu. Welcome to my channel. Today I shall introduce to you the use of chain rule in calculus in differentiation. It is very important for the class 12 student as well as even 11. Little bit they learned. Now let us start the video. Yes, this is the sum, the y equal to e to the power sin x square. Find dy dx. See, e to the power sin x square. Sin x square not in the standard form, so we must use it. Or we just convert it into the standard form, I mean to in the standard formula, and then we shall proceed. And to do so, we assume something for sin x square entirely and x square also, so that it will convert into a standard form, so it can be differentiated directly using formula. And for doing so see, uh, here x square equal to sin t and t equal to x square, correct? Now further see, y become e to the power z. So you may assume any value. Generally u, v, z, k are assumed. And now let's start the sum. Now differentiating both sides, I mean the sum with respect to x. And in order to do so, what to do, just carefully look and must practice it very carefully. So dy by dx is equal to dd. Let's see the how to write the chain actually. For the latter sum, the chain may be done mentally, and for the beginner to practice this type of sum, we must write down the chain in this manner. So dy by dz, look, dz dt dt seem to cancel, and now the dd z of e to the power z, because e to the power z is the standard form, because e to the power x of ddx and ddt of sin t. Sin t also differentiable. And now what is doing now, what is actually substituting, the part is just differentiating in the next step. So the chain rule, the basic of chain rule is what you are substituting, you continue to differentiate it in the next step. Okay, just multiply this and continue. So putting the value of z cos t, it is very simple sum. And second sum also we shall do now. And now see what is going on. So putting the value of t and to 2x already written down at the first time, so this is done. So this is the answer. Now we must see this application in the second sum, and look, the basic of the chain rule is to multiply the differentiation in continuations. So what is substituting, multiply it. Now see the little bit, again the sin xy plus cos xy equal to 1, and it is given that tan xy is not equal to 1. We have to prove that dy by dx equal to minus y by x. If you practice this sum, so in other sum, any type of sum, I think it will be very much easy by you to work out the sums. So here also let us assume xy equal to u, so it become a standard form. And now let us differentiate both sides because it is implicit form, not explicit. Implicit means on both sides xy not given in separation. So let's start the sum. So look at very carefully what is now differentiating with respect to x, both sides of course. This is implicit function. So sin xy is not a standard form, no. Only sin x, sin y, sin z, sin t. These are the standard, and directly you can get the differential part. And that is why now we just take xy equal to u, and so ddu of sin u and see in ddx of xy, because already in the previous sum as I did, anything we are substituting will continue to get the differential of the part substituted, just multiply. Okay, so it is du of sin u equal to cos u, and it is a product rule, x into y with respect to x, so it will be like that, keeping x constant dy dx, now y constant, and ddx of x is 1, so I am not writing in class 12. And now what is going on now, see, that is also minus sin u, then again same thing, add x dy dx plus y equal to 0, because ddx a constant, now it is 0. Now let us proceed. So what to do now? Now just take common x dy dx plus y. Okay, now putting the value of u, let us first arrange the sum, and this is plus minus minus, and then again in the bracket the same thing is writing. Okay, so equal to 0. Now also see what is going on. Now let us take the common, because x dy dx plus y is in the both terms, so taking common, so cos xu minus sin xy is in the bracket equal to 0. Now the sum is almost done. Now so it is two factors, so x dy dx, let us write down the post dividing by cos xy. Okay, now we are going on to divide both sides by cos xy, so that it will become tan xy, and that is why we are doing so. So look very carefully, not difficult, but you have to master. Unless this chain rule, the practice of substitutions, it has become very difficult to work out all sums. You have to do, we need to multiply this chain rule mentally in some applied higher sum. Okay, it is also standard class 12 board questions. And now let's think what to do. Now either two parts, either 1 minus tan xy, second part I am taking first, equal to 0. This implies what? This implies tan xy not equal to 1. It is given, the condition given. Okay, so it is okay. Or the second part is x divided dx plus y equal to 0. From that we will follow our answer. Let's see what is now we are going on to do. And now see, now let us write x dy by dx plus y equal to 0. Okay, so Let us get the dy by dx, x dy by dx equal to minus y. Is minus y, and now see, it is minus y, and from this the answer will follow. So minus y by x, it is definite. Dy by dx is equal to minus y by x, hence proved. So this part is proved. So I think you can do it. Carefully follow this. It is very easy sum, not difficult sum. I think it will be very much helpful to all of you. Practice it and learn these sums and apply this same rule in other sum. Thank you very much.